Good morning. Today we are going over the test for Unit 7 so we can learn from our mistakes and work on those practice works, and we will have retakes after school on Wednesday and Thursday, retakes in class on Friday. So if you have a lot of retakes you want to do, if you have questions on any of the practice work, staying after school Wednesday or Thursday is a really good idea, so I can help you with those so we can learn from those mistakes that we made. With CO 51, there were a lot of us that forgot to classify our angles. So we might have measured correctly and said, yes, this is 60 degrees or close to 60 degrees. This is close to 120 degrees. But we forgot to classify it. If it's 60 degrees, it means it's an acute angle. And if it's 120 degrees, it means it is obtuse. So you did have to write if it was acute or obtuse. Now, down below on 3 and 4, technically, we should have wrote acute or obtuse for both of those also, but I gave us credit for just drawing the picture. So if it is an 80-degree angle, it's going to be less than 90 degrees, but not by a lot. So it's looking something similar to that shape, and it would be acute. Like I said, I did give us a break, and I just counted it wrong for 1 and 2. You still have to retake it. It will be easy to retake if you are measuring correctly. Just remember to label it. 165 degrees is way bigger than 180 degrees, so it looks something like that. And it would be obtuse because it is bigger than 90 degrees. Any questions on these ones? Okay. Now, for this section, I told us that the top are the definitions and the bottom are the examples that we use for 52 and for 53. So our definitions are going to come from that top section, that's its definitions. So the definition of a complementary angle. Complementary means it's two angles that add together to be 90 degrees. Supplementary are two angles that add together to be 180 degrees. Vertical angles are congruent angles opposite each other at a vertex. And definition of corresponding angles are angles in the same location at different vertices. So then the second part is we had to do what the example of it looks like. So complementary angles, if we add them together, they equal 90 degrees. Please stop talking. And supplementary angles would be the two angles that added together to equal 180 degrees. Vertical angles, they have to be opposite at the same vertex. Vertex is where those angles meet. So that is our example where the two angles meet. And corresponding angles, we've got those parallel lines with the line going through. So those are our corresponding angles. Any questions on those? Some of us had a hard time matching up in the right way. When we do the retake, you'll do just the CO 52 or just the CO 53. So they will be separated out. So you'll just do the 90 or the complementary and supplementary and just do the vertical and corresponding. Okay, so doing the retakes, you can just focus on that one set. They're not going to be combined like this. CO54, I can classify a triangle by its sides and angles. So we need to draw and label an acute triangle. So what does acute mean? What is the definition of acute, Lilia? All three angles are less than 90 degrees. So you needed to draw a triangle that had all three angles less than 90 degrees. And it does say to label it. So you can't just draw a triangle. You also had to label it. So you had to put in different degrees that when we added them together, they equaled 180 degrees. Doesn't matter the numbers we put in there as long as they were under 90 degrees. And if I add all three together, they equal 180 degrees. So if your angles didn't equal 180 degrees, if you didn't write angles in there, you didn't put what their measurements were, I couldn't give you credit for it. You had to do both parts, draw and label. For the right triangle, you had to show me a right triangle. So you had to show that this angle either has the box, or you could put that it's 90 degrees. You could put what the other two angles are. The most important part was this, is that we had a triangle with a 90-degree angle in it. That's what I was looking for that one. Draw and label an isosceles triangle. If it's an isosceles triangle, I know two sides are congruent. I could do that by my hashtag showing they're congruent. I could put the same measurement there, showing that that third side is a different measurement. So the isosceles means two are the same, one is different. In a scalene triangle, all sides are a different length. So you needed to show me all sides with a different length. Didn't matter what the numbers were, as long as they were all different. Any questions on this one? Anybody not sure why they didn't get credit for one of theirs? Okay. PO 55. I can solve for an unknown angle in a triangle or quadrilateral. So for this one, we needed to remember that if it is a triangle, all the angles equal 180 degrees. And if it is that quadrilateral, all the angles together equal 360 degrees. So for my first one, 180 minus 100 minus 55 leaves me with 25 degrees. For this one, I know that little box means it's 90 degrees. So I need to do 180 minus 90 minus 40, and I'm left with 50 degrees. For my quadrilateral, 360 degrees minus 77 minus 123 minus 86, I am left with 74 degrees. And 360 minus 77 minus 102 minus 15, I am left with 166 degrees. I would like you to hear this. Any questions on that? All right, this last one, the Pythagorean theorem. Ooh, some of us really had a hard time with this. So let's really pay attention. First question, what is the Pythagorean theorem? Who can tell it to me? Mana. A squared plus B squared equals C squared. So remember, the A and the B are our legs. The legs form the what, Madeline? The right angle. So my C is the hypotenuse. How do we always know which side is the hypotenuse? Which side is the C? How do we know which one it's going to be? Madeline?
It's the one that's right across from the other one.
Yeah, it's across from the right angle. So when we have that right angle, we know the two sides that form the right angle are the A and the B. The C is across from the right angle. The hypotenuse is the C. Now it says solve for the variable. I had some people super close and they just forgot to do the very last step. So let's look at this. We know this is our right angle, so we know this is our A and this is our B. So A squared plus B squared equals C squared. So 15 squared is 225, plus 8 squared is 64, equals C squared. What is 225 plus 64, Jimena? 289. That equals C squared. Is that my final answer?
No.
Now, what do I have to do, Melanie? Yeah, I need to find that square root. So I had some people that were like, oh yeah, I need to do the square root. And that was their answer. You actually have to do the math. What is the square root of 289? 17. So C equals 17 because that is the square root of 289. So you have to make sure that you're doing every step. Now 24 says the leg lengths of a right triangle. I'm going to draw my right triangle. The leg lengths are 8 and 15. What is the length of the hypotenuse? The hypotenuse is the same as our C. Legs are A and B. Hypotenuse is the C. I had a few people come up to me and say, Miss Gambino, these numbers are the same as 23. And I said, yes. Yes, they are. Because Mr. Schultz wasn't checking if you knew how to do the Pythagorean theorem. He was checking to see you knew the vocabulary. That the legs are the A and B, and that the hypotenuse is the C. So we have the exact same numbers. So our answer is the exact same. Okay. You had to recognize hypotenuse is the C. So you had to do the exact same math. Any questions on how to use the Pythagorean theorem? Madison.
Oh, wait, no.
Okay. Any questions on the Pythagorean theorem? All right. So now let's turn our page and look at our next objective. The next one is CO57. I can classify and draw regular, convex, and concave polygons. Classify the polygon by its number of sides and, right, whether it's regular, convex, or concave. Two things. I had quite a few people only give me one. I needed both. So if I look at 25, number of sides, 1, 2, 3, 4, 5, 6, 7, 8. It is an 8-sided figure. It is an octagon. I am not done. Is it regular, convex, or concave? I see that two sides are caved in, so I know it is a concave octagon. Had to give both. For this one, it is 1, 2, 3, 4, 5, so it is a pentagon. No sides are caved in, but those hash marks are not there saying that they are all equal, so I can't say it's regular. So it is convex, because there are no cave-ins happening. Madison, did you have a question?
Oh, I was like waiting. I was like looking forward, like looking, and I was like,
We haven't gotten to it yet? Okay. All right, draw the polygon described. A regular quadrilateral. Technically, just drawing a square shouldn't have been enough. I did give some people credit for drawing a square, that looks like a square, but what should I have had on there to prove that it's a square? To prove that it is regular? Callie? Yeah, the hash marks. Saying each side is the same. That's how I prove that it is regular. Like I said, I did give credit if somebody drew a square. Some of us drew a rectangle, not regular. Regular means that every side is the same length. So it had to look like a square. And on the retake, you have to prove that each side is the same length. So you could write a side length for each side that's the same, or you could do the hash marks. If it is a concave hexagon, hexagon means 6, and it needs to be concave. So mine looked like this. One side caved in, and I've got 1, 2, 3, 4, 5, 6. Any questions on those two? CO58. I can determine whether polygons are similar, congruent, or neither. Answer each question. What does it mean for polygons to be congruent? What is the simple way that I taught us? Jimena? Same shape, same size. What does it mean if they are similar? Madeline? Same shape, different size. They are proportionate. It's just one is bigger or smaller than the other one. Can you wait till we're done? So that's all we had to put. For congruent, same shape, same size. For similar, same shape, different size. So now we actually have to use that knowledge with our proportions to say, are these polygons congruent, similar, or neither? Well, first thing I can rule out if I have different numbers is they can't be congruent because they're not the same size. So now I need to look, are they similar or neither? So I'm going to match up my corresponding sides. And I'm going to do the math. I'm going to take my numerator and divide it by my denominator. And for each one of these, I get 0.5. They all divide down the exact same way, so I know that they are similar. For my second one, again, not the same numbers, so they are not congruent. So I need to decide, are they similar or neither? I'm going to match up my sides. So 8 and the 2, the 12 and the 4. 8 divided by 2 is 4. 12 divided by 4 is 3. They do not divide down the same way. So this is a neither. When I look at the rectangles, I don't necessarily see that they look different. So we can't just look at it and say, oh, it looks to be the same. Looks like it's the same shape, so I'm going to say they're similar. Because they are not actually the same shape. I have to do the math. Cam, I'm not sure what's going on, but your attention should be up front. A lot of us got these two wrong because we were doing our math wrong. We forgot how to do the proportions. Do we understand it now? Any questions? So, Madison, was your question on one of these? Was it answered?
Yeah, I'm staying after on Wednesday.
Okay. Or is it the one that I'm getting to now, the 59?
Yeah.
Okay, so wow, you really did jump far ahead. All right, so let's look at the last one, CO59. So now we know that they are similar polygons. So we know they're proportionate, but we need to find the missing side. So remember, we have to match up those corresponding sides. So I did the long over the long, so 8 over 24, then the question mark over the 18. So match up your sides. Just like we did to see if they were similar, we matched up the sides, and then remember what we do. We multiply, cross multiply, and then divide our number that's left out. So we cross multiply and divide out that other number. So 8 times 18 divided by 24 gives me 6 for an answer.
And I was like, nope, that's totally wrong. That's not right. And
You got it right. That's the answer. For this one, if I'm matching up my sides, I've got 30 goes over the question mark. I can't use 36 because there's no corresponding side. So I'm going to do 15 over 7.5. I'm going to do my cross multiply, divide my third number. So 30 times 7.5 divided by 15 gives me 15 for an answer. For this one, I needed to do the short side over the short side. Remember, we can turn your rectangle, match up your corresponding sides. So short over short, long over long. Cross multiply and divide, and we get 10 for our answer. 8 times 50 divided by 40. Some of us wrote our proportions incorrectly. So you have to remember, if this is my A and this is my B, if I put A on top here, I have to put the A on top here. So you have to match up where your A's go and where your B's go. Okay.
When you did the lesson, did it like say Q&A?
You had to draw it yourself.
Oh.
I told you that you can label them A's and B's. So this was just like our homework. You had to write the A and B yourself. For number 36, matching up our question marks. So I've got 20 over question mark. I started with my A, then 15 over 30. 20 times 30 divided by 15, and I get 40 for an answer. Any question on seeing where we went wrong with our proportions? Doing good with this one now that I went over it?
Yeah.
Did it answer your questions?
You sounded like that perfect girl. Yeah. She's good. Yeah.
All right. Math 6 review. Multiplying fractions. What's our rule when we multiply fractions?
Wait, what?
What's the rule when we multiply fractions?
You have to make it common denominator.
Nope.
Wait, you did. You so. Yeah, you
Bryn, tell me.
multiply.
You multiply straight across. So 5 times 3 is 15. 8 times 7 is 56. Then we have to see, can I simplify it? Is there anything I can divide out of both 15 and 56? There is not. So it is as simple as we get.
Wait a minute. You don't have to make it common denominator.
No, that's for adding and subtracting fractions. Multiplying and dividing, there are no common denominators.
Oh.
What is our rule when we're dividing a fraction? Melanie.
You switch them. The second fraction. You would put when you do 9 over 7 and then.
Yeah. We flip dividing to multiplying, and then We flip our second fraction to its reciprocal. Now we're multiplying, so we multiply straight across. 5 times 9, 2 times 7, 45/14. Can I simplify that? No, that's as simple as it gets. So I could either leave it improper, or I could turn it into a mixed number. 45/14 is the same thing as 3 and 3/14. Either one of those were acceptable answers. So if we're going to solve for the variable n minus 12 equals 31, what do I have to do, Claire?
So you have to do 12 plus 12, and then you can do 12 plus 30.
Now, when we're doing those one-step operations, we need to do our opposite operation. If we're subtracting 12, we want to add 12 to both sides. So n, we want that n by itself. Minus 12 plus 12 makes it a 0. We want n alone, so we're pushing it to the other side. 31 plus 12 is 43. I had a lot of people subtract 12. We were already subtracting 12. Remember, we want to do the opposite operation. The way we check it is to put it back in. 43 minus 12 really does equal 31. If we had kept with that 19 minus 12, that does not equal 31. That would have equaled 7. So always go back and double check your work. For PO 40, n over 6 equals 4. What do I have to do to get n by itself? What is my opposite operation that I should do? Claire?
So you have to time.
Yeah. That fraction bar means divide. So it's n divided by 6 equals 4. So I need to do the opposite, and I'm going to multiply by 6. So if I multiply by 6, 6 over 6 cancels out, multiply by 6, and I get n equals 24, because 4 times 6 is 24. I can go back and check that and say 24 divided by 6 really does equal 4. Claire?
So on the extra credit,
Mm-hmm.
so I got 14, but I realized,
There were a lot of people that put 14.
but
Because a lot of
there
people
has
said
a
7
brother.
daughters and a brother, but each of the
38.
daughters has a brother, so they did 7 daughters and 7 brothers. It is just 8 because those 7 daughters each have a brother. They don't have 7 brothers, there's 1 brother.
14.
So each, it's not 14. Because that would be 7 daughters each has 7 brothers, then it would be 14. If it said they have 7 brothers. But if they only have 1 brother, each daughter has the same brother. Ava.
I misread it, and I thought it was if Mary has 7 daughters, and each of them has a son. How many kids does she have? So
Oh.
I put 7.
Yeah. Sometimes with those extra credits, we have to slow ourselves down to really read what they are asking. Are there any questions on this test? Madison?
Why sometimes you like the same extra credit questions? Okay.
There's only one test where it was duplicated, and I just keep forgetting to go back to not duplicate that one. That was an honest mistake. That was just kind of giving. There's no others that'll be duplicated.
That was the first time I ever done it.
Any other questions on the test? All right. If you are watching at home, I hope you are well. I hope you have a wonderful day.